We tend to think of reality as solid and unwavering. But what if that's just an illusion? What if there are other universes just beyond our perception, unseen yet equally real? This might sound like the plot of a sci-fi movie, but it's actually a serious area of scientific investigation. In recent years, the idea of the multiverse has moved from the realm of fantasy to the forefront of cosmological debate. This shift has come about due to several competing theories within physics. Each proposes a slightly different take on the nature of the multiverse, but all point to the mind-boggling conclusion: our universe, with its stars and galaxies, atoms and antimatter, may not be alone. So let us dive deep into the science and explore what exactly this means for our understanding of the cosmos and our place within it. First, let's start by addressing the elephant in the room. When people talk about the multiverse, it's not referring to a single idea. Instead, there are multiple scientific theories that support the notion of a multiverse, each offering a slightly different take on what it might look like. We'll discuss three of the most prominent ones: the bubble multiverse, the quantum multiverse, and the string theory-based multiverse, the bubble multiverse. The first multiverse model we want to talk about is known as the bubble multiverse, or the eternal inflation model. It's rooted in the idea of cosmic inflation, a theory that attempts to explain how the universe expanded in the first moments after the Big Bang. According to this theory, the expansion happened extremely quickly, around 26 periods of exponential growth in less than a billionth of a second. This rapid inflation smoothed out the universe and set the stage for the large-scale structures we observe today. But what if inflation didn't stop completely? That's where the bubble multiverse comes in. The idea is that our universe is just one bubble in a vast foam of space-time, with each bubble representing a separate universe. New bubbles are constantly forming, each with its own laws of physics and potentially its own version of everything. This means that there could be an infinite number of universes existing side by side, each different from the others. Think of it like the surface of a boiling pot of water. Each bubble is a separate domain, much like separate universes, separated by barriers that can occasionally burst. When one bubble, or region of space, hits another, the space in between them can collapse. But if these two universes collide fast enough, the colliding spacetime doesn't have time to adjust and ends up being stretched. This leaves behind an imprint in the CM, stretching the spacetime in one location while leaving another relatively undisturbed. This difference can appear as a variation in temperature, marking the spot where the collisions occurred. By identifying these temperature differences, scientists can work backward to infer the presence of other universes. Sounds complex, right? Well, it is. But remember, this is just one model of the multiverse. Let's move on to the next one: quantum multiverse. The second multiverse model we want to discuss is known as the many worlds interpretation of quantum mechanics. This model suggests that every time a quantum event occurs, the universe splits into multiple branches, creating a new universe for each possible outcome. Remember those tiny vibrating strings we talked about earlier? Well, they're back. According to this interpretation, these quantum events are associated with the vibrations of strings, which exist in higher dimensions. These strings vibrate in different ways, which creates various quantum events. Each vibration mode is like a separate universe. As the strings vibrate, they create different outcomes, which causes the universe to split and create new timelines. For example, let's imagine a quantum event where a particle can either go left or right. With each quantum event, the universe splits, making both possibilities real in different branches. Eventually, all possible outcomes converge into their own respective universes. This means that in one universe, you made one choice, while in another, you made another. This process continues infinitely, resulting in an infinite number of universes, each with its own unique timeline. However, despite all these parallel universes coexisting, they remain forever hidden from each other. Imagine you're flipping a coin. In one universe, it lands on heads, and in another, it lands on tails. Each outcome exists in its own universe, but the two results never interact or influence each other. It's like a grand cosmic game of chess played out across infinite boards. On each board, pieces move differently, leading to unique outcomes. Yet on no board can you see what's happening on the others. It's a lonely existence. The brain multiverse. Finally, let's talk about the third multiverse model known as the Brainworld model. This model is rooted in string theory, which posits that the universe is composed of tiny vibrating strings. In this theory, the universe is a three-dimensional brain floating in a higher dimensional space. These extra dimensions are curled up so small that we can't perceive them. But that's not all. There can be more than one brain in this multidimensional space, meaning there can be multiple universes. This brings us to the multiverse. In this model, the universe is just one brain among many. These brains can interact with each other in ways that we don't fully understand yet. But when they collide, they can cause new Big Bangs, leading to the creation of new universes. It's like the collision of two billiard balls, but on a cosmic scale. Each collision creates a ripple effect, triggering the birth of new universes. Now here's where things get really interesting. According to this model, every time two brains collide, it's like they exchange pieces of themselves. This exchange can lead to the transfer of matter, energy, or even information. Imagine you have two decks of cards and you shuffle them together. Each deck contains information in the form of card, suits, and numbers. When you exchange parts of these decks, the combination of information can lead to new possibilities. Similarly, the interaction between brains can introduce new features or change existing ones, shaping the characteristics of the new universes that emerge. For example, suppose one brain has a strong gravitational pull, and the other has a weaker pull. When they collide and exchange pieces, the resulting new brain could end up having a medium gravitational pull, something that wasn't present in either of the original universes. This exchange of characteristics can also apply to other physical properties, such as the strength of magnetic fields or the behavior of subatomic particles. The resulting new universes might have combinations of properties that were previously unknown. So not only does the Brainworld model propose a multiverse, but it also suggests that these universes are constantly evolving and changing due to interactions between the brains. This makes for a dynamic and ever-changing cosmos, where new possibilities arise from the meeting of different universes, unveiling the secrets of black holes. While the multiverse is a fascinating concept, it also raises many questions. What does the existence of other universes mean for our understanding of reality? How do the laws of physics work differently in other universes? And can we ever find evidence of other universes? To answer these questions, we need to explore some of the mysteries of black holes. As we mentioned before, black holes are some of the strangest objects in the universe. They have a gravitational pull so strong that not even light can escape. But what if there's more to these enigmatic objects than meets the eye? What if they hold the key to understanding the multiverse? Enter Hawking radiation, a concept proposed by Stephen Hawking in 1974. This theory suggests that black holes aren't completely black. They emit a faint radiation due to quantum effects near their event horizon. Now, here's where things get really interesting. This radiation isn't just any radiation, it's thermal radiation, similar to the light we see from stars. But wait, how can a black hole emit light when nothing can escape its grasp, not even light? Well, according to Hawking, it is possible for pairs of particles to briefly pop in and out of existence at the event horizon. One particle falls into the black hole, while the other escapes as radiation. But there's more to this radiation than meets the eye. It turns out that the radiation emitted by a black hole carries information about the matter that fell into it. In other words, it remembers what it has swallowed. This has led to the fascinating idea that black holes can act like cosmic memory banks, preserving information that would otherwise be lost forever. Now, this raises an intriguing possibility. What if the information carried by Hawking radiation extends beyond our own universe? Could it hold clues about other universes, other dimensions, or other versions of ourselves? It's a tantalizing thought that suggests a deeper connection between black holes and the multiverse. Looking ahead, whether or not the multiverse exists, the idea is forcing scientists to expand their thinking. The multiverse makes us question our assumptions about the universe and encourages us to think bigger, bolder, and more imaginatively. It pushes the boundaries of our knowledge and challenges us to explore new ideas and concepts. And who knows, maybe one day we'll discover that the multiverse is real and that our universe is just one among many. What do you think? Do you believe in the multiverse? What are your thoughts on this mind-bending topic? Share your thoughts below, and don't forget to subscribe for more videos like this one. Thank you for watching, and see you next time.